Okay, in this problem, I know the maximum tension in all of these cables is 600. That doesn't mean all of the cables equal 600. It means that none of them can be above 600. And knowing that, I want to find the mass of the chandelier. Okay, so what I want to recognize is I have 2 points where I've got concurrent forces. Okay, and I have 4 different cables. So it's going to take 2 free body diagrams to kind of figure this out. Okay, so we're going to start with those free body diagrams. These cables are all in tension, so the forces are all going to be coming out. So I'll start with B. Okay, and I just got this horizontal force, which I'll call FBC. I have this force FAB, and that's at a 30-degree angle. Okay, and then I've got a 45-degree angle, FBD, like so. So this free body diagram has 3 unknowns. I need that other free body diagram that I'm looking for at D. Now, that's got what I'm interested in finding. I'm looking for the mass of this guy, so I'm going to have mg heading straight down. That's really what I'm ultimately looking for. Now, recognize I have this force here. Again, this is FBD. This is the same force I had in the previous one. It's just in the opposite direction, and that's because of Newton's third law of reaction equal opposite reaction. So it's pulling down and to the right on B, up and to the left on D. And again, that's going to be a 45-degree angle, so I pop that in like so. Okay. Then I've got FCD. That's a new force over here, like so. Okay. So I draw those 2 free body diagrams. Now for each one of these concurrent free body diagrams, I'm going to get 2 equations. Some of the forces in the x, some of the forces in the y equal 0. What I do is I'll start with the second free body diagram again, where the no what I'm trying to find the m is. Okay, and I think that'll be the best way to start this. So I'm going to go ahead and sum the forces in the x direction. Okay, and I'm going to have FCD cosine 30 and then negative FBD sine 30, not 30, sine 45, excuse me. Okay, and that's it horizontally. MG is all vertical, so I just set that equal to 0. Now I'll sum the forces in the y direction on this one, and I'll have FCD sine 30, and that's upward, so it's positive, plus, because FBD is upward, FBD cosine 45. And now this time I've got my force acting straight down, the weight, and again, that's going to be the gravity 9.8 times n. And I'll set that equal to 0 because it's an equilibrium. Now, I've got 3 unknowns, okay, 2 equations. So again, I need those other equations. So let's go ahead and do the same thing for the other free body diagram. Some of the forces in the x direction, I'm going to have FBC. That's all horizontal, so that shows up there, plus FBD. Now this is the same BD I had previously, remember? And that's going to be cosine 45 horizontally. And then AB is actually going to the left, so it's going to be negative FAB cosine 30 equals 0. Do the same thing in the y direction. Now BC will not show up in this one, so I only have FAB sine 30 and then a negative FBD sine 45. Now notice FBD shows up in every equation because it's in both free body diagrams. Okay, so I've got 4 equations here. 1, 2, 3, 4. And let's count my unknowns. Okay, I've got 1, 2, 3, 4, and 5 unknowns. Okay, now you might be saying I can't solve this, but again, remember that I know that 600 is the maximum any one of these can be. Now, that doesn't mean they're all 600. It means one of them is 600 and all the other ones are less than 600. So basically, I need to find out which cable sees the most force. So what I'm going to do is I'm going to just kind of plow through this okay, and solve for each force as a function of m, and whichever one's largest, then I'll set that one to 600. Okay, so let's go ahead and start with equation 1. And from equation 1, I get FBD equals FCD cosine 30 over cosine 45. Now what I'll do is I'll take FBD, plug it into equation 2, okay, and then just to save some time, okay, from that I'll find that FCD equals 7.17 m. Now knowing that, I can plug that into the equation above and get that it's 8.79 m. So I'm not done yet, but what I know now is FCD is not the largest force, right? FBD is bigger than FCD. Okay, but now knowing that, I can continue down through these equations, plugging in what I know, because now I know, actually, let me do 4 first, because 4 only has one new unknown in it. Because now I know FBD, and I can plug that into that, right? So I can get, let me just take the time to write this one. Sine 30 equals 8.79 m, right? That's what FBD equals, times the sine of 45. And then from that, I can find that FAB equals 12.4 m. So now what I know is that one's kind of the leading candidate to be the largest because it's bigger than the other two, right? 12.4 is bigger than 8.79. But I've got one last equation, equation 3. And again, I'm just going to quickly go through this one and say that from that, I learned that FBC, plugging in what I know about AB and BD, plugging those two values in, I can easily find FBC to be 4.55 M. Okay, so what I know is this is the force, the tension that sees the largest force. So that's the one that I want to set 600, knowing that all the other ones that are going to be less than 600. So I basically say, okay, well then FAB is the one that equals 600, and that equals 12.4 m. And from that, I can find that the mass of the chandelier is 48.3 kilograms. Now, if I plugged this m back into those other equations, I'd see all of them would be less than 600, which is what we're looking for on this problem.